Do you enjoy this beautiful view? Is it relaxing? Remember that this is nature, and everything can change very quick from this beauty to chaos. Of course, these images are a bit unrealistic, but what you see now can really happen to people, and it's real danger. But why these events happened at all? Are all tsunamis the same? No. There are at least two types of events that can trigger a tsunami. Earthquakes generate most tsunamis documented in history. One plate moves under the other, causing an earthquake. Energy released causes the water to rise and generate tsunami waves. Waves then inundate coastal areas. Waters drove back further than normal and joined the next wave. Usually, there are several waves. When an undersea landslide occurs, a large mass of sand, mud, and gravel can move down the slope. This movement will draw the water down, which may create tsunami waves. The water draws back further than normal. Waves inundate land. Waters drove back further than normal. Waves inundate land. There are usually several waves.
We asked a local expert about landslide. Professor Michael Jaboyudov from the University of Lausanne. He kindly accepted to be interviewed for the film.
You see, this is a landslide within a river, giving a tsunami. And what we observed, what was interesting, is that we get the data from the LiDAR before and after, and also we see the wave on the other side. In that case, the test of the simulation was first to use the volume that displaced and to use a shallow water equation to try to simulate the way it moved out. And this is our scan that we know exactly which landslide is there. And then simulation, we tried to get this failure surface. We had half of it because the rest was buried and under the water. I have here the landslide that goes, okay, it's the landslide and of the water. Then there is two equations, one of the shallow water equation for the landslide and also for the river. And you see that with the dry, this is always difficult to do, is that the water goes on the dry side.
This is Lake Tawe. You can ask yourself, why a lake when we are speaking about tsunamis? Well, tsunamis can also happen in lake, for example, it happened once in Lake Geneva, or here in Lake Tawe. A tsunami produced by paleo landslide. A About 40,000 years ago, a 5 cubic kilometer section of the lake's west wall collapsed. At speeds greater than 20 meters per second, the slide completely traversed the lake bottom. And in less than 10 minutes, stranded the blocks we see today. Wave height easily exceeded 50 meters. This is a true mega tsunami. The wave struck the east shore in 5 minutes, and the south and north one in 7 minutes. Once in motion, the lake oscillated several times.
The importance of tsunamis generated by landslide has only become widely recognized with the Papua New Guinea event in July 17, 1998. When a 7-magnitude earthquake struck the island and killed at least 1,600 people. Here is an approximate numerical model of the tsunami.
Earthquake monitoring centres scattered around the South Pacific registered the Papua New Guinea seaquake within minutes of it occurring. A warning centre for the Pacific is based in Hawaii, but the earthquake was so close to the PNG coast there was simply not enough time to warn the villagers.
From all the media reports I've heard, there was 30 minutes between the earthquake and the tsunami striking, and I don't think anyone can warn anyone about something like this 30 minutes away.
The tsunami was generated after a major seaquake measuring 7 on the Richter scale, which was centred just off the Papua New Guinea coast. Experts say the only chance locals had would have been if they felt the quake and fled to higher ground.
An earthquake of this type actually lifts up part of the sea floor relative to the other. So you're basically moving a mass of water up during the earthquake, and that creates a difference in the height of the sea surface, and the water has to flow.
Norway. Country of the fjords. Can this place be protected from tsunamis? In fact, fjords trigger landslides, which leads to tsunamis. Some people imagine tsunamis in fjords like this. In fact, they are not so apocalyptic. But the consequences are devastating. Norway Geotechnical Institute created an actual numerical model for such an event triggered by landslide. Thankfully, there is now an alert system in place.
Verktøyet vi har for å trygge menneskeliv, det er kontinuerlig sanntids overvåking av bevegelsene i fjellet, og hvor det da i etterkant er etablert planer for evakuering i hver enkelt kommune, hvert enkelt bygdelag, og det er etablert systemer for varsling av innbyggere, blant annet via telefoni gjennom løsninger fra UMS.
The UMS alerting technology ensures that local residents and tourists can continue to feel entirely safe residing in this beautiful area.
Have a great time.
There we go. See those? Okay.
About communication of risk, Anna Skolobik is an expert from University of Geneva.
Communication of rare events is really a very difficult task. First of all, because most of the people that you target in your communication strategy do not have any experience of the type of event that you are, expecting. There is most of the time no memory if it's rare events, and also the risk perception as a consequence of this is usually very low. So you are basically asking people to imagine a worst case scenario that they didn't have, really in their mental model. So that's particularly difficult for communication. So I can imagine that if that's the case of this tsunami that you described for the Lake Geneva, an operation of, really raising awareness has to start as soon as possible. First of all, of course, the areas that are most exposed have to be identified. Then, you need to map the communities in these areas. So who are these people? Who can be the most vulnerable people? And then try to target communication strategies for these people, addressing their needs. So you need first to figure out what do these people know or don't know about this type of rare event. Maybe some of them can imagine it, or maybe most of them are completely unaware of it. And if this is the case, then you really need to organize together with the local authorities a number of initiatives to raise the awareness and to let people know what they could do. Switzerland is really very advanced concerning earthquake risk prevention and communication. The Swiss authorities and emergency managers are really investing a lot in training local champions, so people that are really knowledgeable about risk in different communities. Social media are the best, one of the best tools that we have nowadays, not only for disseminating information to the public, but also for getting information from the people that are suffering, for example, an event, or that are observing something that not always the local authorities can observe. So more increasingly, authorities, not only in Switzerland but around the world, are using images, for example, provided by local population that are, really images about risk issues or topics that are, that could generate a risk. And so in this type of two-way communication flow that is now possible thanks to the new technology has to be implemented. So the type of problem, it is very difficult to train citizens to collect data, reliable data. Even if it may seem simple to ask, did you felt the earthquake or not, the type of question that you have to ask are very much detailed. So they need to train the citizens to have some type of knowledge on how to roughly quantify the possible damages in case the earthquakes are not very strong. For example, how to quantify a rupture into a building, so how they can measure that.
About the possibility of tsunami in Switzerland, we had to contact Professor Flavio Anselmati from University of Bern.
These lake tsunamis, they occur related to mass movements. So to answer or to investigate how often these lake tsunamis occur, we have to realize how often our slopes become unstable underwater. And these slope instabilities are mostly caused by seismic shaking. So somehow it reflects to the question, how often do strong earthquakes occur in Switzerland? And in order to destabilize these slopes, we need seismic intensities of, let's say, 7, 6 to 7 on the European macroseismic scale. And depending on the area, such events happen, let's say, to give you a number for a specific area, maybe every 1,000 years, 1,000 or 2,000 years. So for a given area, these are rather rare events. But we have the other events that do not require an earthquake, so we have spontaneous collapses, or we can have landslides, subaerial landslide-induced impulse waves in the lakes, which are also a substantial hazard. So, in general, these are rare events, but it means that we might not have the historical consciousness that they may occur at a given place, but that makes them even more dangerous.
Do you think that in Switzerland the monitoring is enough, or should we do much more?
There I would distinguish between the waves that develop from rock masses that fall into lakes, because they are easy to monitor, and then these dangerous rock cliffs above the water, I think they are monitored quite well. We also have a series of new proglacial lakes that develop in the Alps, and then these hazards we see. For underwater slide, those are the classic tsunami ones which we investigate. I think we did not do enough hit, so we don't know really where are the charged subaquatic slopes, if an earthquake will happen, where are the slopes that become destabilized. This is an open field, and this is also part of our current research, that we try to investigate the hazard potential of future seismic shaking events. So we have to somehow quantify where are the unstable slopes and what would the resulting wave, what would the inundation be on land. And there we have to do quite some work, and this is why we are active in that domain. We try to investigate some lakes as case examples, we do numeric models of wave propagation, and on and on and on. I think there we have to do more.
Thank you a lot for your time.
Good, pleasure. Successful studies and a nice class project.
Thank you.
Thank you
Have a
so
nice
much.
day.
Have a nice day. Bye.
Bye.
Okay, à bientôt. Au revoir.
Au revoir.
Au revoir.
Est-ce que ça marche? Do it works? Okay, just so. If it works, let me know. I didn't say shit, bullshit. Shit, oh no.
C'est bon? It's okay?
Action!